All right, here's a little help on that homework assignment, page 330 and 339. Make sure you check out the problem numbers again. We finished yesterday in class, we talked a little bit about, or today in class, depending on when you're watching this, how to figure out these types of problems, 22 to 26, and then we ran out of time. And I finished by showing you that if you saw that the two distances from Q to the side of the angle, the big angle, MNP, the big angle, there's a bisector, angle bisector NQ, and we know that Q, that point on the angle bisector, is equidistant from the sides. That's why you see 18 and 18. Yeah, that's the distance to the side. The big clue about important factors, those have to be 90-degree angles, how it's measured to the side, in order for this to work. Knowing that little piece of information, that that's equidistant from the sides, means it is an angle bisector. And then we can talk about those two angles being equal to each other. So we set them equal, solve for x, and we get x equals 13 by isolating the x. So little algebra, if you need help on that, let me know. The next piece is, the question says find PNM, the angle PNM. That's the big angle. So we have to put 13 back in to the angles that we have, which are the two small angles that are bisected in this particular triangle. So if I put 13 back in, I get 44 degrees for each piece, 44 degrees for each little angle. Well, I want the big angle. So the big angle is the sum of those two smaller 44-degree angles, and you end up with 88 degrees. Now, 25, similar, something else you want to know about these particular angle bisectors. If you notice, by all the markings that are in there, we have two triangles. Do you notice the left triangle there in yellow? The green triangle on the right? Those are actually congruent triangles. Can you see the parts? We have angle, angle, side. Two angles on the left that match with two angles and a side on the right. And the order is such that the side is not between the two angles, so it's angle, angle, side. So we know these are congruent triangles. This happens every time you have an angle bisector like this that's equidistant from the sides and all these markings. We actually create two congruent triangles. That means all the parts match. We can actually go with that. Well, let's erase all that. So the question is, I'm supposed to find PQS, so I put a question mark in there so you could see the angle I meant by that, PQS. The little angle on the left, and I know that the angle on the lower right there is 48 degrees, while the one that would correspond to it, since they're congruent triangles, would also be 48. I can find now the missing angle that I'm looking for because I know that three angles add to 180 in a triangle. So 48 and 90, the one other corner, and then this unknown angle that I'm trying to find, let's say it's x. Okay, that's the PQS I'm talking about. If I solve for that, or the way you usually do it, you guys add up the angles and subtract it from 180. You know that intuitively. That's fine. Or you can just set the 3 equal to 180 and then do a little algebra and find that it's x is 42. So that's the measure of that angle there. That is the question, so we're done. X equals 42 degrees. And now to the next piece. There's a lot in this next problem, 27 to 30, and actually this is what we're kicking off Thursday with, is just talking about the cool things about an incenter. We just got started on it in our previous note packet. Now we're going to fill in the gaps. The biggest deal is, I want to tell you right now, the incenter actually creates 3 pairs of congruent triangles, and I'll show you where those show up. So that actually helps us answer all these questions in here, like what sides are equal to what, and angles, and so on. And then there's also this, because there's so many right triangles in there, we actually use Pythagorean theorem to find one of the missing sides. So it's a pretty powerful problem, but let's go through the details. The thing that we have right now is that I can go through and find a bunch of the missing angles if I'm really careful about this. In fact, I'm going to back up a little bit more. I went to the wrong piece there. Where is this? I can show you guys. No, that's fair. I can give you that. Things that you want to label. These two angles down here in the lower left are 28.5 and 28.5 respectively, and I'll show you why. So what we have is, I know those two angles are 28.5. Let me show you how I got there, and it'll help a little bit. Well, an incenter made of angle bisectors. So if I'm given an angle in the corner, I know the other one near to it, the adjacent angle, is also the same measure. So 28.5 for that lower right-hand corner. That means 33 for the upper right. Together, the big corner angles are 66 and 57 if I add the two smaller angles together. And that way I can find the big angle E in the lower left, because I know all 3 big angles of the big triangle add to 180. So 66, 57, and that big angle E, I know they add to 180. Find the big angle E, and it's 57 degrees. Split that in half for the angle bisector, and I get 28.5 apiece that you see in red there. That allows me to do a lot of things. There's one more piece of information. So incenter, angle bisectors, allows you to find all those angles. Okay, that's something you've got to know. The next piece you want to do is, Remember, an angle bisector is its property is equidistant from the sides, marked in green there. So you have to note that those are equidistant. That little those structures in there are hard to find sometimes in the triangle, but if it's an incenter, there's going to be a marking that shows the distance from the incenter to the sides, and it'll have a perpendicular marking there, and those are all congruent. Okay, these are a whole bunch of right triangles. Can you see them in there? I see 1, 2, 3, 4, 5, 6 right triangles. And those make 3 pairs of right triangles that happen to be congruent to each other. Let me show you which ones are congruent and why. The top 2 triangles are congruent because there's an angle. They both have a 33 and 90 degree angle each, and a side that matches because it's on the incenter. So that's angle, angle, side congruent. So those top 2 are congruent to each other. So let me delete all that stuff. So I shaded those in, and then the lower right-hand 2 are congruent for the same reason, angle, angle, side, as are the lower left pair. So shaded in some nice spring colors for you. Those are your matching or your congruent triangles. Anytime you've got an incenter, you can run with this. So this will do us a lot of good as time goes on. So keep that in mind. Maybe we can add that to your notes, pause here, and work from that. The rest is, okay, I got this 14.9 in there. I kind of forgot where that went, if you guys are having trouble. I can't see well. Well, it's actually that 14.9 is the EF length on there. So I helped clarify that. I think the other one that's confusing is the 13 up top. I'll clarify where that goes. That's actually the center down the middle. That is, so I'm going to answer a few questions now that I can. First, 29, DAC. DAC, if you want to go trace out DA and C, it's that small angle up by A, the vertex A up there. It's the one on the right. It's 33 degrees, we know, because of the bisecting property. So that was pretty easy. The other thing is now I marked that 14.9 for EF. Well, since the triangle below it, the adjacent triangle, is congruent, they're both shaded kind of light green there. Those 2 sides are congruent because we're talking about congruent triangles. So I take that 14.9 and I can put it down where ED is. I can copy that over. And actually, that's what number 28 is asking. What's ED or DE? It's 14.9. So I'm just duplicating that distance. I think you can find DEP, no problem. Just look at the angle. You'll find out exactly what the measure is. The next big property that we want to take care of noting is that how do we find PB? We're going to use the Pythagorean theorem to find that. So, oops, sorry, I got a little, we're gonna clean that up. Just a second. Let me pause this and fix it. Okay, cleaned that up a little bit. Sorry for the big mess. Now, so what I've got, let's put those numbers back in there and get everything kind of cleaned up again. There's 14.9 that we duplicated over. Now PB. Notice what PB is. PB is that little distance from the incenter P to the side B. We know it's equal to the other distances to the sides. And PB is part of a right triangle. Now if I pull that right triangle off, stick it over on the side I'm looking for, PB, I'll call X. I know that the longest leg is 10.9, so I labeled that. I think I put 10.9. Maybe I put 10.5. Whoops, I'm going to have a miscalculation here because I used 10.5 instead of 10.9. Anyhow, the process is the same. And then the hypotenuse 13 is because AP in the picture there is a length of 13. If you can't see what those are in a picture, don't worry. Always ask me if you can't read it carefully. But that's a nice right triangle. We're going to solve the Pythagorean theorem. You guys know leg squared plus leg squared equals hypotenuse squared. So that's x squared plus 10.5 squared, sorry, it should be 10.9, equals 13 squared. You want to subtract the 10.5 squared. So I'm getting x by itself. Of course, figure out what those two numbers are, what they add up to. It's subtract them, use the calculator, whatever it takes. So x squared equals 58.75. But I want x, so you square root at the end, and you're home free. 7.66 is about the length of PB, so I'll put it over there in the answer. That's one of the other things we have to do within in-center problems. Because we have a bunch of congruent right triangles, some of the legs we'll find by Pythagorean theorem. Okay? Well, that's the end of the story on those. I'll move on to some others later, but that should be a good kickstart to the assignment.